Anyway, so guys, on this page in your notes, let's go ahead and fill this in. It says all natural orbits in our solar system have a elliptical shape. So go ahead and write that in. Elliptical is basically the same as saying oval. But we're not going to say that anymore because we're in high school. Now, deviation from a circle shape can be measured and is called, let me explain why we do this. So if you think about it, guys, like I've got my hula hoop up here. What's the shape of the hula hoop? Is it a perfect circle? No. It's a little bit off. Okay? What's happening right now to its ellipticalness? Is it more or less elliptical? It's more elliptical. Okay? Now, when we talk about that, though, it's kind of like, it's hard to just kind of say, well, you know, like right now it's kind of like, it's like moderately elliptical. Well, it's sort of elliptical. It's kind of elliptical. Like you can't use like wishy-washy terms like that. It's too subjective. You need a way to make it objective. In science, how do we make things objective? We use numbers, people. Yes. Okay. Because you can measure it, someone else can measure it, and you're going to come up with something very similar. So deviation from a circle shape can be measured, and when we measure that, it's called eccentricity. So it's called eccentricity. All the formulas that you guys need to know for earth science are in your earth science reference table. Right now, please go ahead and write in the formula for eccentricity. It's found on the first page of your eCert. Question, Jenna? You do. But you'll notice it doesn't have the dots. Yeah. Sorry, my mistake. I noticed it after I copied them. You need the dots. You'll see why. So anyway, right now, go ahead and write in the formula for eccentricity. And you might be looking at me going like, whoa, what's foci mean stuff? I'm going to tell you. Don't worry. I got you covered. I'm looking out for you. So front page of your eCert formulas. Owen, what's the formula? Yeah. Divided by the length of major axis. Okay. Then, let's go ahead and label those features on here. So you can see here, guys, there's an orbital path. A planet would be orbiting around the sun. What do you guys think is located at this position here? No. There's actually nothing. In order to draw an ellipse, you actually need two focal points. You guys know what the plural of focal points might be? Henry does. It's that foci word, yeah, foci or whatever. Yeah. These are the foci. This will make more sense when we do the lab tomorrow. Just to abbreviate, I forgot to mention, guys, instead of saying the distance between the foci, often we just abbreviate D divided by L. So this is D. That's the distance between the foci. And then from here all the way across is the length of the major axis. Okay. So I'm going to get you guys started, and then you guys are going to do this on your own. But we're going to go ahead and do two problems here. So first off, the formula is equal to E. I'm sorry, E is equal to D divided by L. So I'm going to measure. You guys are going to do this too, but I'm just going to get you started because I really want to be really specific so you guys can see what I'm doing. So as you look at this, I keep hearing like a little muttering. Is that muttering? So as you look at this, what's the measurement, guys? You always measure from the center of the foci to the center of the other foci. What do I got? 3.2 centimeters. Okay? This is centimeters. Even though you see the mm on there, this is centimeters. What it's saying is each single line is a millimeter. So I'm going to put in 3.2 centimeters. And then you measure the length of the major axis. 7.6 centimeters. And you got to be right on. Sometimes what students do is they're kind of like, well, you know, it's like really close to 7.5. That's easier to put 7.5. No, you put the full number. Right now, calculate these. Calculate the eccentricity for ellipse 1 and 2. Do it to the nearest thousandth. Please do it to the nearest thousandth. So using these measurements, you can go ahead and make your final calculations. I've got 3.2 divided by 7.6. That would give you 0.421 because you need to do it to the nearest thousandth. One other thing to consider here too is if you have to round or not. You can see there's a 0, so you don't have to worry about rounding. So I'm going to go ahead and put 0.421. Now, one thing that's kind of cool about eccentricity is there's no units. That makes it easy. What happens is these units, because you have centimeters divided by centimeters, those cancel out, leaving you nothing. So you don't need any units. On the next one, again, you're going to measure. Your formula is D divided by L. You measure between the star. You're going to have 1.3 centimeters. Then you have 3.8 centimeters. Calculation for that. 1.3 divided by 3.8. That gives you 0.342. Again, that 1 is low enough that it's not going to make this round up. Now, if it was a 5 or higher, that would make this round up. It's going to be 0.342. Again, there's no units. Now, this is the point where I kind of want you to think a little bit at what you're looking at. You can see that this shape over here is more elliptical. In other words, it's more squished. It's less like an ellipse. Then look at the number, or the eccentricity. The eccentricity is higher than the one over here. In other words, what that means is when eccentricity is higher, you have a more elliptical shape. So go ahead and write that down. Higher eccentricity equals higher elliptical shape. Or a more elliptical shape would probably be a better way to say it. I'm going to put that down instead. So more elliptical shape. Some other things you got to know. The highest number, or the highest eccentricity you can have, is going to be 1. It's the highest you can go. And there's some reasons for that I'm not going to go into. You really don't need to know it. But you just got to know that the highest number is 1. The lowest number you can have for eccentricity is going to be 0. Now, if you think about it, if you have an eccentricity of 1, the shape that that's going to produce is a line. If you have an eccentricity of 0, that means there's no eccentricity at all. In other words, it's a perfect circle. So this is going to be a circle, or a perfect circle. Now, this is kind of coincidental, but if you look at this, a good way to remember this is a line looks a lot like a 1. Okay? And then a perfect circle looks a lot like a 0. So if you're trying to remember, well, I got a 0, what's that going to look like? Just remember that looks like a perfect circle. Okay? That's it for the lesson. If you have any questions, please let me know. Thanks.